Okay, Gauri, here's your question. In the attached slide, why are moles of D formed due to consumption of A and B the same? I guess this is the statement that you're worried about. Yeah? Okay. The point is, this will happen only when the reactants are mixed in stoichiometric ratio. To understand this, take an example. Let's take this equation that you're very familiar with. 2H2 plus O2 gives you H2O or 2H2O. Yeah, so 2 moles combines with 1 moles of oxygen to give you 2 moles of water. Now let's forget about the oxygen for a second. Okay, what you would say is that 2 moles of hydrogen, yeah, are giving you 2 moles of water. Okay, what you could now forget about the hydrogen. Alright, and what you would say is that 1 mole of O2 is giving you 2 moles of water. Okay, now let's say instead of 2 moles of mixing 2 moles of hydrogen with 1 mole of oxygen, let's do, for instance, 1 mole of hydrogen plus 1 mole of O2. You know that this is only going to give you half a mole of water, yeah, and you're going to be left with some H2. Okay, if you went by just these two reactions over here and then looked at what were your reactants, you would say that 1 mole of H2 should give you 1 mole of water, yeah, because in here 2 moles of H2 gives you 2 moles of water, so 1 mole of H2 should give you 1 mole of water. Okay, if you look at the water, quantity of oxygen, looking at this reaction, you would say 1 mole of oxygen gives you 2 moles of water. Yeah, so what you would expect is 1 mole of oxygen giving you 2 moles of water. This is what you'd expect. What you have here left is half O2. Yeah, this is what you'd expect. Okay, but this is not mixed in stoichiometric ratios. Yeah, and therefore you can see here that the moles of water produced due to consumption of one reactant is not the same as moles of water formed due to consumption of the second reactant if you followed proper stoichiometry, yeah, or if you looked at the balanced equation, which is this one. If you did mix them in a correct stoichiometric ratio, which means neither of these two is the limiting reagent, okay, then you can see that consumption of hydrogen gives you 2 moles of water, consumption of oxygen gives you 2 moles of water, moles of water formed due to consumption of hydrogen is moles of water formed due to consumption of oxygen. In this case, however, you have mixed them in non-stoichiometric ratios. Okay, now by just simply looking at how much reactants you have, okay, 1 mole of hydrogen is going to give you 1 mole of water, 1 mole of oxygen is going to give you 2 moles of water, theoretically speaking, and as you can see, they are not the same. That's the point I'm trying to make. Okay, that if mixed in stoichiometric ratios, yeah, which means in the ratios of the balanced reaction, the moles of product formed due to consumption of one reactant is the same as moles of product formed due to consumption of the other reactant. I hope this is clear. If it's not, let me know.